Consider this function. It's a rational function. What is the domain? Well, you know you can't divide by 0, so we would take that denominator, set it equal to 0, and solve for the value of x that is restricted. We would find that -2 is the only number restricted from the domain. So your domain is all real numbers, not -2. In interval notation, we express this -infinity to -2. We don't include the -2, so we use parentheses, and then everything from -2 to infinity. This is our mathematical way of saying all real numbers, not -2. Well, what about the y-intercept? Now, when you find a y-intercept, you do so by putting a 0 in for x. If you put a 0 in for x, you could just cover it up, pretend like it isn't there. Or we could take the usual route, substituting 0 for x and solving for y. That's 3 times 0 plus 12 over 0 plus 2. That's 12 over 2, which is 6. We would express this y-intercept as an ordered pair, 0, 6. To find the x-intercept, you can simply set the numerator equal to 0, or you can put a 0 in for y when you're looking for that x-intercept. So we set this equation equal to 0 and we solve. Well, we do so undoing this fraction, reversing division with multiplication. These x plus 2's cancel. Anything times 0 on the left is still 0, so it's true. You could set the numerator equal to 0 and solve. We move 12 to the other side with subtraction. Undo multiplication with division. We find the x-intercept to be -4. We could write that as an ordered pair, -4, 0. Well, what about the asymptotes? Our vertical asymptote comes from that denominator and the domain restriction. The one thing x cannot be is -2. So x equals -2 becomes our vertical boundary. We write our asymptotes as equations. To find a horizontal asymptote, we need to compare the degree of the numerator with the degree of the denominator. The highest power up top is 1. Same is true for the bottom. When those degrees are equal, we find our horizontal asymptote dividing the leading coefficient up top by the understood leading coefficient down low. If it's a horizontal boundary, we'll write it as the equation of a horizontal line, y equals 3 over 1. So y equals 3 is our horizontal asymptote. Since we have a horizontal asymptote, there will be no slant asymptote. Let's tie it all up with the graph. Let's begin by plotting our vertical asymptote. We said x cannot be -2. So your graph is going to get really close to -2, but no touching. We also have a horizontal boundary where y is 3. So our graph is going to get close here, but again, no touching. Let's plot our x-intercept. It was at -4 that we touched the x-axis. Let's also plot our y-intercept. Our y-intercept is 6, so we'll plot that on the y-axis. Okay. We need some more points here. Let's choose numbers around that which is forbidden. X cannot be -2. Let's get close to -2, like -3, -4. Not -2, but something to the right of -2, like -1, 0. When x is -3, we find the y value to also be -3. If x is -4, y is 0. When x is -1, y is 9. If x is 0, y is 6. Let's plot these points. We've got one at -3, -3, -1, +9, way up here. Okay, that's enough information. Let's connect these dots, make a nice curve that approaches these asymptotes, but no touching. Okay, that is the graph. Done.